So good afternoon, and let's start lesson 6. Let's talk about how obtain from dense cloud point DTM, digital terrain model, and DSM. So we start from the data that that is loaded and is furnished on website, and you can use for the exercise. You will start from the use of Metashape, and so the base is the after aligning the photos is the type points that represents the first 3D model after align photo. So we have just for reason of time, we have just construction the dense cloud point, and using this command, this build dense cloud point, and here we have check all advanced resource, calculate point colors, so that as seen to all seeing point cloud the correct color, and so we make the high quality. So in this way the system, they calculate a very elevated number of points that is right here, and so we can we have a complex model with point cloud. We can be observed that we have also a scattering scattering point that is not necessary to construction the DTM, and so the area is complex because we have the infrastructure, we have the house, we have the trees, so we need to filter the cloud points if you want to obtain only the DTM. So first filter that was applied is spacing filter. We have reconstruction another dense point cloud using this command, dense point cloud filter dense, that make a space between the point cloud. We can choose, for example, 0.03, but you can also insert 0.06, and the number of point clouds that are considering in this way is more or less than the first dense point cloud. So is the way to eliminate, to select it, to not consider some point clouds. But the trouble is that how consider only the elements, only the points that will be used for digital terrain model, only for reconstruction the area and the surface of terrain, excluding the house, and considering break lines like like this. So we need to filter. We have make this type of processing using first we can classify, or also if you prefer you can remove scattering points like this with the selection. Can make selection, cons, you will remove the cloud points that we not allowed to construction the DTM. That is the focus of this lesson. So we have also a noise to filter. So this is an operation for manual filter. So first is classified point, assign to a predefined class the point that is built the dense cloud point. So we have more predefined class. The standard predefined class is ground, vegetation, building, road surface, car, and man object. Clear that is the first way to start the classification of the dense point, because the final object is to find the ground control points, because the ground control points and in this situation, the ground control points and the points of linear structure that will be used for DTM. So we go here, tools, dense cloud, classify points, and start classification. So we can also filter the ground control point, for example, using this function tools, filter by class, and here we can select the point assigned to a single class. For example, we have we can tick all ground control point and road surface. So in this way we really simplify the dense cloud, and if you want to use this dense cloud, we need clear to update the dense cloud. So we go to here and we can update this dense cloud. If you don't update the dense cloud, the filter is only a temporary filter. So we can remove filter, and is only a visualization. Only a visualization of selected of filter point cloud. Clear is not perfect because there is some point cloud that does not represent the real surface, and so we need, for example, selection like this point that is noising, and cancel that. also this that represents the roof of the house. Okay, and if you want, we can update and make definitely the modification on the of the cloud points. So let's try to construction to build them. To build them, because also them is a raster model, we need to choose the system of coordinates cartographic system, and also add other parameters like the source data, dense cloud, interpolation to make extrapolated. And here, which point cloud we want to use for construction dam? We make only ground control point, ground point. Okay. You choose the final resolution. So the dimension of grid ETM, and also if you want you can set the boundaries, so you can extract a single part of the TM. We have just elaborated this, and the result is that. So how you can see is a 2D model, and we have also plotted the footprint of drone capture. That is possible to So is it possible to show the position of the dam elaboration with base map, like map satellite or map normal, to check if is the correct position? The last elaboration of this lesson is to create contour. We can generate contour, right, left, right tax of mouse, generate contour. And so after elaboration we have the final results of the contour. We see that is more accurate, and so we have a contour from distance from 1 meters, and we prevent the intersection. So we can select the contour, clear is possible that also export the DTM or set different scale of color. If you need to show DTM in another way, it's possible also to export and save this palette of color. if you want to export to use or in other format, or to load in this system, or also in Google Map, you can do directly from here. And we can also export the contour that will be put in here in the shapes, because there is a vector element, and we can export like this in a vector file, like a shape file, DXF file, or KML file. So now we have just see the way to create the DTM, only the digital terrain model, and so we can show the DTM in different way, with also with hill shading model. So with hill shade modeling you can get more different visualization, and so you can check also if you have some region of DTM that is you need to correct. For example, here there is some errors in DTM, and so we can expect it that can be influenced the representation in contour, because here we have probably when we make cloud filter or cloud point, when we make a filter of cloud point, we don't have purge all point cloud of roof house, and so we have something distortion in this region. In effect, the DTM is work some well, but we have some distortion with some rest of cloud points that we need make manually selected to purge, because we have some part of point clouds that represents after filtering have a noising and representing the roof. So is not a best DTM, digital terrain model, because they contains it contains some old information about structure, about houses. They are present in this area. So that's clear. Now in this exercise I want to make you understand the difference between DTM and DSM, because DCM is digital surface model, and they will contain more information, and also the whole structure of the houses, and so like that. So what we see, if you want to recreate a DSM, you need to reset the first filter that you make on dense point cloud, and reset this, restart classification, and update finally, if you check that the dense point cloud is okay, you can update the dense point cloud, and so you build another dam, and another dam we have checked that we have also other point cloud, and that they will contain all information, just houses, just the noise of trees present in this area, and all other information. If you check, is much more differently, because they contains the footprint and elevation of roof and the structure of the houses, and so if you extract here the contour, then we see that the final results of contour is more different, because they will interpolated all this information of trees, of noising, of this. And so in this case, the final results of elaboration of contour is this. Is more confused, because they have the interpolation with whole area of trees, area of road, area of roof house, and so the contour is not a realistic contour that can be represented the surface of the only surface of terrain. So the same results we can visualize also in if you are using drone deploy. You remember that in lesson number 3, when we start elaboration and present the open platform drone deploy, after you upload the file and they start elaboration, it's clear that we can, you remember that obtain different type of results. The first visualization is the photos, the orthophotos. And the second visualization is clear, is plan earth that represents the model of slope degree of the area, and we have also the elevation. The elevation, you can check DSM, the model that contains just all information, houses, trees, roads, surface, and only terrain that is purged by all other elements that they don't represent surface of terrain. So is in drone deploy is an automatic elaboration, is about realistic, but if you want to extract contour, you need to set and to apply a monthly payments. So for the concept that is that the importance of filtering the point cloud. If you want to obtain a realistic digital surface, digital terrain model, you need more attention in the phase of filtering the dense point cloud. You need to check, to control in various ways, because not whole automatic or semi-automatic filtering system is always correct, because I will show in the first part of this lesson, filtering dense point cloud is a complex way, because you need first classify, you need first spacing. If we have a big area with very elevated number of point cloud, you need to filter, you need to spacing the information, because you have a high elevated number of points, and after you need to classify, you need to assign for a class, and so you can make this in two ways, with unsupervised way, that means supervised is an automatic way. You have predefined classes, and the software try to assign that these classes, but not in all cases is always correct. So the best is check this and make also manual selection, for example by colors, because if you have some colors that represent trees in a region, you can assign that for class of trees. Also, we need to control the noise of point cloud, because there is some points that is scattering and is out of control, points that we need with is positioning in wrong way, for example like this. So if you want to make a very accurate work, you need to delete this manually. So is the phase of drone elaboration data that need more accuracies, more knowledge. So because when we pass this phase, you can filter the point cloud, and if you are sure that your work is good, you make just a good selection of point clouds. So here we have some points that is noisy point. You can update the point clouds, and finally we have the definite point clouds that is ready is the base to create and to generate the digital terrain model. So clear also the first how is set the ground control point is more important, because for example in this case the ground control points is a ground control points, but they doesn't control they doesn't very fit well the area, because are all in this part of the area. So generally the ground control points they will be set of the angles of the area, one here, one here, one here, one here, and make as we have well explained in lesson 2, we have need to make a grid of ground control points, one here, one here, one here, one here, one here, one here. So to calibrate the model of elevation and prevent the only distortion of the area. So that's finally all I need to advise us for a good elaboration of dense point cloud. So, thank you for attention, and see you at next lesson. In next lesson, we are talking about the last part of elaboration, that is the extraction of orthophotos, the correction, the elaboration to have a rectifier, have the angle that is generally we have a pitch and roll when we acquire the drone, and we have the processing of rectification, and to extract updating imaging of the area. Thank you.